is on, but I don't see my face.
All right, try again. I just changed your role. You should be able to turn it on now.
How start? Or do I have to push start my video?
Yes.
Yep.
Okay.
There we go. Hi, Mark.
Howdy. All right, I see the mute button. All right.
All right, Sean, I think we're ready to go. I don't know where Thor is, but he'll join if he can.
Okay.
Yep, I'll let you guys just go ahead, introduce yourself and get started, and I'll keep watching for Thor on the other side.
Okay. We'll try again. Maybe. Okay, I think we're good now. So, good afternoon. So thank you for all those that are able to call in today. Put together a couple of videos this afternoon showing, stepping us through the Interstate Bridge, which if you're in the Portland metro area, more than likely you've gone over this well, quite a few times. So anytime you need to get from Portland to, or Oregon to Washington on I-5, Interstate Bridge will help you get there. So definitely a part of E-Week, looking for projects, sites, and other things that bring a bunch of different engineering topics together. And this is 100% one of those. So I'll go through some quick introductions, and then we'll dive on in. So Jamie, or I guess I can start off. So my name is Sean Miller. I am a department manager for a company called Power Engineers. We're a consulting design company, predominantly in the electrical power side of things, which we'll touch base a little bit on today. I've been doing this work, starting off as a field engineer for the last roughly 8 years, and have an education and background in mechanical engineering, manufacturing engineering, and then work as an electrical engineer. So a little bit of a diverse range. And then just as a side note on coming out of school, what's that look like on salary range side of things? Stepping out of school was roughly in the, I think around $50,000 a year. So about going rate on electric or engineering or on that side of things. So I'll turn it over to Jamie, and I am muted.
Okay, can you hear me, hopefully? I am Jamie Miller. I'm a resident engineer with the Oregon Department of Transportation. I've been working with Oregon Department of Transportation for about 11 and a half years or so. An interesting piece of information you may want to know is kind of like a salary range for this position. It could be from $91,000 to about $125,000 for the position that I am in, and it's a manager role where I'm managing multiple construction projects, ranging from bridge replacements on I-405 to putting curve warning signs in the ground. So we do multiple different projects out of my office. So Mark, I'll pass it off to you.
Howdy. Yeah, Mark Gross here. I'm the Odot Highway supervisor for the Interstate Bridge.
Muted, Mark.
You hear me now?
Yep.
So Mark Gross here for supervisor for I-5 Interstate Bridge with ODOT. And crossing Columbia River, and I have a crew of 9 employees that operate the bridge and do maintenance on the bridge, and been managing this bridge for 20 years, and have been with ODOT for this year will be 26 years with ODOT. Anyway, let's see, and all different ranges of whatever it takes to keep the bridge function, operation, working with construction office for bigger projects. Then there's the maintenance side and small little projects and contractors and highway maintenance work, lubrication and very general maintenance, and work a lot with electricians. Electrical is a massive function to keep up on a drawbridge, and drawbridges are just so notorious for vibration, and vibration is one of the worst enemies for electrical. Anyway, and then I guess my salary range for the month is about $4,500 a month. So, and I see Thor, so I think it's his time.
And how do I sound? Can everyone hear me?
Sound good.
Okay. My name is Thor Alvarado. I'm the assistant project manager for ODOT at the Sylvan Construction Office. Our office delivered this contract from the beginning as an idea to get this done, and we went through the whole design process, through the bidding process. It was a different type of bidding. It wasn't a low bid type process. It was a specialty alternative, what we call an alternative type of contracting, through construction and now through closeout. I've been with ODOT 13 and a half years. Prior to ODOT, I was a bridge builder in the private sector. My ODOT salary range goes from about $7,000 to $8,500 a month. And so, yeah, I built, so when I went back, built bridges, and I built truss bridges like this, and I'd worked on mechanical bridges, lift spans and draw style type bridges for about 22 years before I came to ODOT. So, Sean, I'm going to mute myself and we'll go from there.
All right. Thanks, everybody. All right, so without further ado, we'll dive on in. So what we've pulled together, definitely it would have been great to be able to get everybody that's on the call this afternoon out and walk through the project, or walk through the bridge, but that's a little tough to do, especially in the times of COVID. So we're doing a video presentation instead, and we'll be stepping through that with some different videos pieced together. Some coming from ODOT that you may have seen through YouTube and other press releases, and others through a GoPro attached to a hard hat. So definitely throughout this, feel free to keep those questions coming into the questions in the chats, and otherwise, we'll give it a start. All right, sounds like the audio is not working, so let me do a redo on the share. and
If
get
you,
that.
when you share your screen, make sure you hit the share sound.
Yep. Thought I hit it the first time, but. Okay.
Horses and a few Model Ts. They had a
Able to hear it this time?
Yes, we are.
Okay, going back to the start. Thank you.
The Interstate Bridge has always been fascinating. It bridges Washington and Oregon across one of the biggest rivers really in the world. During the time of the World's Fair, 1905 in Oregon, there were ferry boats going across. The backup was so far into Washington. That was the impetus, the World's Fair, to really start to get this bridge in motion and to get it going. We opened what is now the northbound span of that bridge in 1917. It was the first major bridge across the Columbia River. It was an enormous event for this region. It wasn't necessary to be much wider than what you'd see for a couple of horses and a few Model Ts. They had a toll on the bridge initially that was designed to help pay off the bonds that were used to build the bridge. That went away sometime in the late 1920s. As the bridge got busier, as cars got bigger, as the Pacific Northwest continued to grow, there were so many lifts that a new span was needed. We put in what is now the southbound span. That opened in 1958, 41 years after the first bridge opened. The bridge today is owned by Oregon and Washington, and it's maintained by ODOT. We have a staff of about 10. Now, this includes the bridge tenders. They're the ones who raise and lower the bridge. The excitement over the opening of the old Interstate Bridge in 1917 was enormous. It really changed so much in the area in the way that bridges can. Bridges are literally bridges between people. They make connections, they're economic, they're social, they're political. There's a lot of different elements that go into putting a bridge in. You can't really overstate how important this bridge has been in the Portland area, in the Vancouver area, and really to the two states. This gives us our connection.
All right, and just real quick, going forward from here, doing some on-site or the on-site walkthrough. Some of this, Mark did an excellent job providing us input throughout the walk, and in a few sections, just too noisy with traffic and other stuff. So we'll be providing some commentary throughout, but again, keep the comments coming in the chat side, and be working to answer those or pausing if we need to throughout. So starting off in the electrical room of the Interstate Bridge, and Mark going over how or pointing to how the bridge is powered.
This panel first, and then the ATS, and senses whether we're getting electrical utility power. If you're not, then it jumps over to the
Backup generator.
Kilowatt generator here. And, this one was replaced in the 90s. It had a smaller generator, and they upgraded to this larger diesel.
How many kilowatts is this one?
250 kilowatts. Yeah, it is. It's got to drive. It's got to have enough to drive both fans and the lights and all of the other electrical features, the house, all the traffic gates. So it's got a lot of power needs. Plus, it has to have a decent enough push if there's a lot of weight on the bridge, snow, ice, that kind of stuff in the wintertime, wind. So this thing does it.
And we're right under the freeway.
Yep.
Yeah, this is span one of the bridge right here. Amazingly, it's this deck roof. It stays pretty tight here. I don't ever get leaks. Wow. Yeah, I know. You'd see it if it was cracked.
Yeah.
I know. It is this the construction of this is pretty amazing. So
That is.
yes.
How thick's the deck in between here
It's something that was built. I'm sure it's not very. I'm sure it's probably somewhere 6 or 8 inches thick is probably not. It's, you know, something that was done in the 60s, 50s. You know, this direction was built started in 1956. It was opened in 1958.
Okay.
So you know that construction.
Yep.
Right there, all that stuff was built kind of lightweight.
Nowadays, it'd be 2 foot.
Yeah,
Yep.
exactly.
High performance.
So it's not heavy duty.
All right, in this section, the VFDs were pretty loud, but going through and just pointing out the variable frequency drives that take from that control power, lower, or the income and utility power that comes in the initial room that was at the start, and separates that out or sends that out to the electrical devices that we'll be seeing a little bit later in the machine room and other areas. Mark, anything you want to add to there?
Can you hear me?
Yep.
Yep. Okay. Yeah, this equipment here now, this electrical cabinets, these are located on Pier 2, which is out in the river at the Bridge House.
Nowadays, it'd be 2 foot.
Yeah, exactly.
And so then everything we were in that first room, all that power, all of that heavy power comes to this room here, and this is where the VFDs, the contacts, the Allen Bradley PLC computers that are ready to control all of the major controls that move the bridge that you'll be showing in the next slides, as far as the actual machine rooms that move the bridge. And of course, there's a few other pieces of technical equipment in that bottom floor of the bridge house. There's 3 floors, and there's some heavy camera equipment and backup UPS equipment in that room here, and river gauge equipment, some National Weather Service equipment, some other computer and phone, all our heavy phone equipment. So this is all a massive equipment room that everything floods into to give us all of our needs to operate.
Thanks, Mark.
You bet.
All right, and looks like we got 2 quick questions. Can touch base here on how is vibration frequency measured? Do you have a certain limit that the bridge should not pass to prevent resonance? I guess I've never taken any measurement on frequency. It is just by the electricians on how when the damage is repaired, we can tell just by the human feel of the amount of vibrations, and you feel it when you're standing on that bridge. You can feel the movement of the bridge continually because of the traffic, and the traffic is just starting to create that vibration. However, I'm sure there is some wind vibration that the towers take into play when there's heavy wind. Like today, we've got some pretty gusty wind today, and but I've never measured it on this bridge. I've never measured the vibration. I just know that it's a factor. Sure. Mark, do you know what the average movement of the bridge is roughly in heavy winds?
Movement as far as flexing the towers? Is that?
Yeah.
No, I don't think it moves much. I mean, it moves, but it's not a quantifiable amount that we've ever been that concerned of identifying.
Okay, thank you. So yeah, from my side on the mechanical side, and the question noted resonance in there. There's always the famous bridge for Tacoma Narrows. If you haven't searched for that video, that's definitely a resonance question. But what, like Mark was saying, the bigger problem and what we see also in the electrical side of things is just that constant vibration, just that constant shaking, even if it's not whirring up to a resonance point, that constant vibration is slowly jittering stuff apart. So, all right. The next question of who pays for the electricity for the bridge. Assuming ODOT.
ODOT pays it, but however, it's a 50-50 share cost bridge. So in turn, WashDOT will pay 50% of that total cost of electricity once a year. So it's but in the first off piece, we cover everything, and then we later bill the state of Washington 50% of all costs of the bridge in one lump sum invoice.
Awesome. Okay, well, we're jump back into the videos. The next part, we leave the electrical rooms and we start heading on up to the machine room. So we still got it. So as we're walking through this section, just add some commentary of definitely for anybody that's driven through a construction zone, for all of us that work on the side of roads or within right-of-ways. Anytime you're driving through a construction zone, you're driving through our office in most cases. So definitely us on the engineering and technical side, we got to take that into account. Is the project site, is the project itself, is it safe for the project team? Is it safe for the contractors and the owners that are out there? Is it safe for the general public? But it's definitely as much planning and preparation as we can do in that. It is 100% up to, in cases like this, as well, the participation with the general public. So just as a general reminder, if you're driving through a construction zone or just driving in general and you see somebody on the side of the road doing maintenance, upkeep, or new construction, you're coming through our office space. So keep the speeds down if you wouldn't mind. We'd appreciate it. So trying to look out for everybody else, but we can always use the help too. So we're starting to step into the machine room, and the audio picks back up here in just a minute, and Mark starts touching base on the mechanical side, picking up from where the electrical now terminates and starts getting transferred into mechanical energy, mechanical and actual motion.
Room. This is the machinery that makes the bridge go up and down, and of course electronically, and then back here we've got a physical motor that I can manually fire up and then run the bridge from
hydraulically,
manually and controlling. Of course, with radios and with contact with the bridge tender. If for some reason, total loss of power, electrical, or some other kind of failure, we could get the bridge up and out of the way. So this bridge here was built in 1917, so this was the originating shack that the bridge tender used to run And of
Keep
course,
everything
this
operating.
machinery's been all changed out. It used to be all giant open gears and band belts and wood brake shoes on the drums
You'd have to sit in here and run the levers.
he run levers, and he had a small little 6-cylinder Continental motor over here that he would drive the bridge with. And massive, stage of gears to. This is the height gauge that the bridge tender would drive the bridge up and down to and identify how high he needed to lift for, and then come down. And it's a worm gear driving up and down, and we were able to save it and reattach it to this. This is not the original shaft, and so we reattached it to this shaft. And we still have it in operation, and we use it when we drive that little diesel motor.
That is cool. I was wondering about it.
Yep, that's what that is.
How long have you been in this role again, Mark?
20 years.
20 years.
Yeah,
A long time.
yeah, it is good. And then this is because of all this new electrical equipment. This thing's climate controlled in here, insulated. None of this had these features. It was all steel walled and cold, and they had a small little coal stove, and the oilers would haul buckets of coal up here to keep warm in the winter, and I'm sure lights weren't, they didn't really have much for lights. They probably did things by little lanterns and stuff back in 1970.
A lot of carbon monoxide.
Oh,
Yep.
Yeah, exactly. Exactly. So, but for the most part, a lot of lubrication needs, and then of course the output of this shaft ends up coming outside here to the cable drums and the drum gears and the pinion gear, the output, and then of course these drums are a line in, line out cable winching. They essentially, you look at this similar system of winching, like log winching, or your worn winch on the front of your front bumper of your pickup.
Yep.
You're just pulling. So when essentially the thought process is you're essentially winching the bridge.
All right, we'll take a brief stop here for 2 questions that came in. And so what type of engineers work on this type of project? I guess Mark? Or
Mechanical and structural and electrical. Those are my 3 main sources for all the needs, the main needs of this structure. Did that answer? Okay.
Yeah, and then for the maintenance, I know Jamie's worked on some smaller, more pedestrian bridge and other items, and those definitely the civil, along with licensed surveyors, making sure it's within the right of way. And I know that we've worked with quite a bit of environmental engineering and hydrology groups for any time being around a waterway. So second question, what are the greatest factors that influence the decision on what materials to use? What are some of the strategies used to decrease the cost of building? I guess just toss in there to that of that, I believe the first span, Mark, was 1917 and the second span was 1956. So at this point,
Yeah.
1917, it was probably what was available and on hand. definitely not the availability of selection that we got nowadays. 1956 got a little bit better options, and Mark in the video touches on that a little bit more as we climb up. But
yeah, it wasn't. Yeah, I mean, on those times of our culture, yeah, I mean, we definitely nowadays we have such a wide array of options and materials and stuff for repairing. However, the structures are still of those older materials, the northbound steel and stuff, some very low carbon steel. So we don't do any welding on that structure at all, and very limited amount of welding on the southbound structure. But some, mostly if there's repairs needed, it's drill and bolt and plate and fix cracks or weak parts. We'll stiffen up with plates and bolts and replace rivets with bolts, and better bridge bolts, grade A 325s, and I don't remember what I said on the video, so play the video and I'll.
Yep. Will do. So we had another question that just popped up and we'll touch base. We'll do a roundtable at the end and touch base on that one of what was our career path, or what was our paths that got us from high school to where we are today. So give us all a minute to think back, because it's been a bit of time since we were there. All right, back into the so we've left the machine room at this point, stepped out the door, and we are working our way up into the we're still on the original trestle, and working our way up a couple flights of stairs. So here we go. Oh, I guess this section we were still fairly close to the bridge deck, so it was pretty noisy. Just one of the things as we start going up through here, keeping a lookout, especially as Mark explains and goes through more of this, and look at the structure again. This section that we're climbing up into was built in 1917. So the stairwells or the stairs that we're using to access and other things like that weren't a part of the bridge at that time.
Right. They were built in the 60s. The stairs that we're climbing up now were built in the 60s. So, yep. So that is definitely a portion of engineering as well, is sometimes how to get to where you need to go on a project, and other times how to add it on to something that wasn't designed. Because if we were doing this in 1917 when it was opened, we would have been climbing up the structure on the side, not going up a nice set of stairs. Yeah.
So, all right, I'll turn it back over to
Bridges, we don't really rebuild any new ones.
Yep.
Anymore, not so much around here. Now, I know down south they still do because everything's so flat.
Yep.
But around here we're trying to find every way to. Well, of course, this new structure, it's gonna tower up around this reef right here, and then come down. But it's not going to be as high as the clearance as this is. But they're trying to, and the Coast Guard will end up determining what that is, which you'll have somewhere. Right now we can get at low water, zero river level point, we can get about the old motors and everything to not have to work so hard because they had a more challenging time of balancing the bridge back in their early days.
All right, so continuing on up, and as the Mark mentioned there, that counterweight cable off to the side. And again, just taking a look at the structure as climbing up through here, all of the piping, all of the cabling and other stuff. Of course, it's can't just run stuff straight across. You got to take that as an engineer into account. How are you getting power to something that the whole center section of it lifts up and down? How are you, if you need to get hydraulics or anything else?
Structure here is, of course, almost 300 times lighter on each counterweight. These are about 650-ton counterweights versus these 900 here.
Okay.
And of course, in the 50s, the Eisenhower period was approaching for interstates. So limitations on how heavy duty highways and highway bridges and stuff were to be built had to be taken into consideration. This was really building hell for stout railroad type structures. Because this thing used to support a rail. It had the center track had rail trolley car on it. So it was built heavy duty, and it was Harrington Waddell, railroad bridge builders and designers. So this thing is really built heavy duty compared to this one. This one was designed and built by WashDOT, and it's a much lighter weight.
So yeah, we started to have more heavy truck traffic going through that section, and again, just we're approaching up to the counterweights. So if you've definitely, again, if you've gone through the I-5 bridge, you've seen those from a distance, and we're getting much closer to those, what those actually are comprised of. So we continue on up the span. I guess Mark or Tor, anybody have anything you want to add in?
No, not at this time.
All right. So
Not at this time.
all right, thank you guys. So yeah, dropping into another ODOT release, doing another great explanation of what it is that I'm about to look at up at the top of the structure itself.
Essentially at the top of the southeast tower there, next to the crane, it is the large wheel that is attached to all the cables, and it's the wheel with the shaft that goes in the center of the wheel, and then there's two big pillow block bearings. That is all one unit, and you can see the new ones on the barge, or which are called the shivs. The shivs are the keeper of the cables. The trunnion is the special axle that is in the center of that wheel, attached with the pillow blocks so that it can rotate smoothly. That is a trunnion unit. And then that will go up and replace the older ones that are up there currently right now, that are from the old bridge times that came with the bridge back in 1917. The trunnion is essentially the axle that really supports all the weight of the cables and the bridge hanging on that sheave. The stresses have over the years put onto the outside areas of that axle where we've developed some small cracks.
Okay, so we've stepped up a little bit closer. We'll be going up the final flight of stairs to the counterweights here. Shouldn't be audio through this section. Yeah, and the part to touch on this, and I think Mark touches on it in the video here in a second. But those cables there, the lift cables, under extremely high tension, As Mark noted previously, I believe the east span is a counterweight of 650 tons and the west span 900 tons. So all that, not all that is balanced on the cables individually, but a significant portion, so that it's balancing in between the bridge and what the bridge deck needs to lift, and yeah. As well as mentioned before, all these cables, of course, you got to get your power up there somehow. So running across the structure, across the top of the structure, because when that can't just run it across the bridge deck, since the bridge deck's going to be going up and down. Along with somebody running a boat through there might not be too happy if they run into a power line. Okay.
Yeah, hey, Sean, I'll add, so most of the aerial cables that are crossing from tower to tower are Odot cables. There's some that are towards the west end there. Those are Odot and WashDOT. We allow private utility companies to hang their cables and their communication routing up and over and across, rather than to get from Washington into Oregon. So, you know, your Comcast, your cable and your internet connection, telephone, all this Google and connection and all of that is coming through those fibers in those cables, and that's in efforts of not going submarine down underneath the riverbed. So they commissioned and permitted, and we've allowed. So that's what those cables are. So just a clarification.
Great, thank you, Mark. Right, we're just about to hop up onto the So yeah, of what was covered in that earlier video of what is a trunnion, and showing those parts and pieces that are housed inside of this section. That whole grouping of equipment was lifted up there during that during the construction this last summer. During the period of time where you weren't able to use all the I-5 bridge to get through, and replaced it, along with looking into the top of those counterweights and seeing what's in those a little bit, or in addition to them to balance the loads out. Because it's not a constant load, as we just had with that large ice storm and everything else. You add an inch of water across an entire bridge, that's a lot of weight. You add an inch of ice across an entire bridge, that's a lot of weight that doesn't go anywhere until it thaws. So the counterbalance has got to be adjusted as it goes. So, and last video here, closing us out kind of on the video portion, then answer more questions. Mark's touched on this throughout, but anytime we build whatever structure it is, electrical, mechanical, civil, structural, even environmental projects, engineers come up with the initial design, we build it, we put it together, we get it out there, we support construction and constructing it, but then we got to maintain it. And so one portion of engineering definitely is building the first project, or building the item. But then for the rest of its life, it's maintaining that item. It's that maintenance and upkeep that needs to happen to keep whatever that is, or a group of items, keeping it functioning the way it needs to. Mark covers that well in this release from Odot.
My name is Mark Gross. I've been with Odot for 24 and a half years. The Interstate Bridge, extremely important. It's a double vertical lift span bridge. And this is just that time to start replacing parts that are very old. We've been planning since last year. So we've been removing the feet and the pins. They are the foundation in which the span to be able to hold still while traffic can move across it. The pins connect the bearings to the bridge, and the bearings bear all the weight. The wear and tear is the vibration. Vibration is bridge's worst enemy. 8 pieces that we ended up lifting and putting in the back of that pickup bed. And then that'll go to our shop. What we're doing is we're recycling. We're going to cut these bigger pins down to this size. They go to the machine shop and get machined and retooled.
Probably do a light pass and then a light pass.
Okay.
And they're hot.
They are going to take those pins and ultrasonic test them and make sure that the steel is all good inside and there's no hidden fractures that we can't see with the naked eye. If it all is good, then we will be reusing those. It's going to be close, and it is neat to see that old pin being remilled, and it's amazing to see what it actually looks like underneath. So these are the bridge feet. Oh, he's getting ready to weld a broken crack. See the crack, the V, and they'll do a certified weld on there. They are parts, some are 50 years old and some are over 100 years old. So we're gonna be putting those same parts back underneath the bridge. The pin's gonna go over here, and then we're gonna slide it in. Meanwhile, years down the road, we'll be replacing other parts.
All right, so that brings us to the end of the video portion of it. Hope you enjoyed a brief climb up, I think 230 feet to the top. Mark, somewhere around there, head from the notes. So hopefully this was a little less stressful than actually walking all the way up to the top of it, but it is a nice view once you get up there. It's something that we can't take everybody to. So jump over to the question that we passed on a little while ago of what was your path from high school to where you are today? And I guess I can start off on that, and Jamie can hop over in here. So for myself, graduated from Oregon High School back quite a few years ago. Was seriously looking at either going into the military or going to school for engineering. Decided to end up going to school for mechanical engineering. Got a bachelor's of science in mechanical engineering, and then stayed on for some master's work in manufacturing engineering, and then got out of school and was looking for, or had some job opportunities. One of which happened to be for myself in the electrical utility industry and electrical power. Wasn't something that I was as familiar with, but with an engineering degree, definitely had enough background in three-phase power and other sides of electrical, and there's enough cross in between engineering disciplines that allowed for a good transition into that. And for the last 8 years, I have been in a field engineer or engineering type position. And so that's my brief coverage over roughly the last 16 years, getting from high school to where I am now. So hand it over to Jamie.
Hi, Jamie again, and I'm just using his computer instead of biting with the controls. So in high school, I actually had a presentation. I was in a woodshop class where the Oregon Institute of Technology came to do a talk about the college. And I was like, hey, that sounds like an interesting college I'd never heard of. And so I had decided I wanted to go into actually electrical engineering to begin with. I went down there and promptly realized that I wasn't enjoying it. I was in the labs and realized if I didn't enjoy the lab work, I probably wasn't going to enjoy it for a career. So I made a career change to civil engineering and finished out there, got my bachelor's degree, and then joined the Oregon Department of Transportation as an intern and worked my way up now to the resident engineer. So that's my background. Thor, do you want to go?
Yeah, so I graduated high school, then I went into, I was at college and I started working part-time for, like I said, I built bridges. I ran into this construction superintendent and he said, hey, you look like you could use some work and you're a starving college kid. So I started building bridges, started taking night classes, slowly but surely. I took enough night classes. I got into the estimating part of the projects. I got involved in the design build, alternative contracting, and bidding process, running work, running crews. And then one day I said, I might as well use my degree. So I applied for Odot, and I got into Odot as an inspector, and then I worked my way up. For the last 5 years, I've been an assistant project manager.
All right, hand it over, Mark. How'd you get where you are today?
Geez, let's see. When I was a kid and graduated high school, I was just a farm kid working on the farm, and the farmer also had a small contracting business, and so I got into construction, swinging hammers and building commercial buildings and operating equipment, digging ditches, and just started working. I've been working forever, since I was very little, but I can't really remember too much time not working. Anyway, and then went into the military and went into the engineering part of in the Army, and operated heavy equipment and built roadways and roads and airstrips and what have you with the military in the Army for several years. Then I hired on to Odot, and in the maintenance section, and did highway maintenance. And of course, ODOT's got very many facets of maintenance, and then stepped over into the role of bridge maintenance, and did a lot of bridge maintenance on the fixed structures. Not so much the drawbridge structures, a few times. And then I-5 Bridge needed a manager and put my name in to take care of things and take care of my family. And so that's where I've been for most of my life here now, is here at this bridge.
Thank you, Mark. Okay. Any other questions out there? Waiting for, got just a few minutes left. So while, if anybody's typing, I'll just add in of definitely there's, from my perspective, as a mechanical engineer, now playing electrical engineer for a living, doing more than playing it, but there is a lot of overlap in engineering disciplines. And as Jamie mentioned, there's definitely some opportunities during a college education to step off from one engineering discipline to another. If you looked into something and were thinking, you know, mechanical is really interesting to me. I really like moving stuff that's moving, and I really like how that goes. And then partway through your sophomore year, you've really had mostly the same classes in freshman and sophomore year as a civil engineer, as a licensed surveyor, as a structural engineer, and even somewhat as electrical engineer. So there's, as she stepping off into engineering as an educational path, or a higher educational path, it's not a decision that's made freshman year, first term. There's always a good opportunity to be reassessing that as you step through it, along with some opportunities. I've definitely worked with plenty of folks that have came the military route, and either working with the CBs or Army Corps of Engineers, NAVFAC, different groups like that, that either stay on in that role, or then move over into the private sector later, or state sectors and supporting that. So there's a lot of ways to get from high school to engineering or engineering or technical trade. There's a lot of ways. So as all four of us mentioned, we got here from one way or another, but it doesn't have to be the only path for yourself. So. Yeah. All right, I guess no other questions popping up. So, and we're coming up to, or we're at the top of the hour. So offer up for any other closing comments from Mark or Thor or Jamie.
I have nothing to add. I just really wanted, I do have something to add. The fact that the 5-6 different types of engineers it takes to do, if we were to rebuild a project or rebuild this type of bridge, it's just amazing, all the disciplines involved, and all the trades, all the craftsmen persons that it would take to build a structure like this. So you know, this was one of those once in a lifetime gigs we had here.
Yeah, thank you, Thor.
No, I don't have anything more to add. I think I'm good. Thank you guys for need to put this out to folks, and maybe it can be redone. People can see how things are.
Sure. All right. Well, thank you, everybody that was able to call in today. Greatly appreciate your time. And certainly if you got questions or comments about engineering, be sure to reach out to your, well, I would assume your school counselors or others, or any engineering school also normally has a great resources group to just shoot a question over, get a hold of somebody, ask some questions, comments, get those thoughts rolling on it. Never hurts to ask. It always hurts to not ask. You never know what doors open if you don't reach out and see what opportunities there are. So appreciate your time and have a good afternoon.
Thank you, Sean. Thank you, everybody, for joining. I appreciate your time. All right, have a great weekend.
Thank you.
Thank you.
Thank you.